This is such an amazing problem because without using a calculator, it looks huge and messy at first and seems impossible to simplify. But with the help of a nice math trick, it becomes beautifully simple. What we can do is assume a variable t equals 70. So 71 becomes t plus 1, 72 becomes t plus 2, and 73 becomes t plus 3. It becomes square root of t times t plus 1 times t plus 2 times t plus 3, and then plus 1. Now here comes the clever trick. We can take this t and t plus 3 together, and t plus 1 and t plus 2 together, and multiply. So first group is t times t plus 3, multiply them to get t squared plus 3t. Second group is t plus 1 times t plus 2. Multiply this, t times t is t squared, t times 2 is 2t, 1 times t is t, and 1 times 2 is 2. Add them to get t squared plus 3t plus 2. Let us now make another substitution. Let a equal t squared plus 3t, then the expression becomes square root of a times a plus 2, and then plus 1. Now multiply a times a plus 2, that gives a squared plus 2a. But hey, this is just a plus 1 squared, because p plus q equals p squared plus q squared plus 2pq. So if you take p as a and q as 1, we get this identity. So finally, square of a plus 1 squared gives just a plus 1. Now recall that a was t squared plus 3t. So the final result is t squared plus 3t plus 1. Now plug in the value of t as 70. So t squared is 4,900. And 3 times t is 210. Add one more and you get 5,111. That was super duper cool. So good.